Okay, final project. So, part one, game documentation. So, allow me to present my best version of Network Omega Race game. So, I was using client server design architecture in the setup. The client controls player one, while server control player two. So, um, I also implement a client-side player predictive algorithm, with target chasing. Well, the dead reckoning predictive algorithm could potentially reduce message transmission, but it tend to produce significant positioning error on client side during unfavorable network conditions, especially with high packet loss rate. So consequently, I opt for the client-side player prediction algorithm. So in order to simulate adverse network condition both on server side and client side, I have configured the game to include simulated loss, minimum latency, and random latency. So specifically, uh, simulate loss at 0.25, minimum latency for 0.1, and random latency for the jitter 0.01. So it should help create a bad network environment. So furthermore, I also developed a version of Network Omega Race game that incorporates dead reckoning predictive algorithm, but which I will show you later. So the physics. So let's see. For the client side, go to game side. As you can see, the physics is not being updated. And now let me show the game. So client side. Oops. So in my screen, left side is server, right side is client. So let's hit play. So the server is definitely the best experience because uh, it's server. And to lay in mind, press N. Yeah, it's very smooth. Let me try to cue that ship. Maybe one more time. Oops, that's kind of hard. Maybe use the mine. Was that cute? I guess it's run out. Okay, so I will try to play it on client side. You can definitely feel the latency, but with predictive algorithm, it definitely smoother. So let me try to lay a mine. Press C. Yep. And yeah, I think that's it for the demonstration. Okay, so part two, network management. I've chosen to design my network manager class using the singleton pattern, as our game only require one instance of it. So back to code on the server side, network manager initialize its creation through a create method right over here. So it's called right inside our load content function within the game. So here and yeah, so now the network manager doesn't just create the server; it also responsible for communicating with the client, and it achieve this through a method I call message to client. which enable other class to send messages to the client. But what about incoming message from the client? Well, our network manager has it covered. It process incoming message using process incoming message. Well, how surprise, which ultimately call this function right over here. So message from client, and this message deserialize the message and use the add to input queue function. And eventually goes to here, and it adds the data messages to the input queue of our data queues. Now let's switch side and look at the client. So go this side. So the network manager initialize a server connection by broadcasting a request on local subnet, which is here, right? So the message discover local peer. Once it's receive a discovery response from a server, the client then start the connection. So the client side network manager mirrors the several counterpart quite a bit. It too has a create method, invoke in content, load content function of the game file. It figure a message to server method, which, as you might guess, enable other classes to send messages to the server. So the network manager on the client side also handle incoming server message using its own process incoming method. It deserialize message through the message from server. So it's this message right over here. So and queue them up in the data queues using add input. So go there. It goes here. So use this method add to input queue method to queue them up in the data queues. In conclusion, by using this approach, we ensure that network manager interact primarily with the data queues. It gives us a clear, and better architecture for managing our network communication. Now, part three, in my system, the data queues which process messages coming from and going out to the network are handled by the message queue manager class. So, message queue class. Okay, so this class employs the singleton design pattern, just like before, as our game only need a single instance of it. Upon initialize the game, we call the create method. Let's see, of within the load content function of the game. So it's right over here. Yep. Depending on depending on the mode, our message queue manager will behave differently. So in record mode, it open a record file here for storing your gameplay data. So but in playback mode, it goes over here. So in playback mode, the program read all the messages along with their execution time from the record files. Those messages are then added to the input queue of the data queue for subsequent processing. So to manage incoming and outgoing messages, the message queue manager class provide two methods. Now let's go next. Add to input queue adds incoming messages from lindering to the input queue. However, in playback mode, incoming messages from linear are ignored. And now add to output queue, add outgoing game message to the output queue. Again, in playback mode, those outgoing messages are discarded. The message queue manager also deals with sending outgoing messages, which is handled by the process out and send message method. I believe right over here, process out, process in. So the messages are sent according to their destinate delivery method and destination. Specifically, messages are sent to the network if the destination is network or local and network, and added to the input queue if destination is local or local and network. Finally, the process in method manage incoming messages. The only exception is in playback mode, where time reply incoming message immediately set the client's current time. Other type of incoming messages aren't triggered or act upon until the game's current time matches the incoming message's execution time. In record mode, before an incoming message is acted upon, the program calls the serialized method from the record file, rather, over here, class, recording both the current time of the message's execution time and the message itself to the record files. So with this upside, we have effectively designed an organized system that manage and process all incoming and outgoing messages from the game. Now, moving on, part 4 for messages. I think we should start by take a look at our data message class diagram. So our core messages, we have fire input message, fire missile message, lay input message, lay mine message, missile pose, position and angle message, rotate move message, shape position and angle messages. All those messages require a data field to specify whether the message is for player 1 or player 2's player's data. Those messages therefore inherit from the data message of player class. Other messages like collision event message, time request message, and the time reply message inherent from the data message class itself. Now, the data message class is inherent from the D-Link node class. This is used for message pool mechanism, which I will talk this later. Now let's focus on data message class. This class it includes the message type, execute time, destination type, net delivery method, and sequence channel. So the execute time data field is used to record and playback to. Destination type, delivery method, and sequence channel data field are used to specifying the delivery method. The message type are used for specify the type of message, and this data field should be serialized to raw data after deserialized from the raw data. The program will know which type of message is received from the network and create the correct type of incoming message. The message type is the first data field to be serialized. The data message class include obviously will include the serialized and deserialized method, as well as execute an abstract message to act on its data when received, and recycle abstract class used to message for the message pool mechanism. Now moving on back to our diagram, let's take a look at the data message of player. So this class include player type data field to specify whether the message is from player 1's player data or player 2's player data. For all the message class inherent from the data message of player class, the player type data field is the second data field to be serialized. So this class also implement serialized method and deserialized method to serialize and deserialize the player's type data field. Okay, next we go back to the diagram. The rotate move message. This class is inherent from the data method of player class. It includes two additional data fields. The horizontal input and the vertical input, which are third data fields that are and the fourth data field to be serialized. Now, this class, definitely will implement the serialized and deserialized method for the horizontal input data field and vertical data field. This class will also doing the execute method according to its superclass player type. It will execute the player 1 or player 2's shape move method and rotate method. Now, for the recycle part, the recycle method calls the message pool manager message pool manager's recycle method to return the message to its associate message pool. The frequency is low and the message should be reachable. And so my program use reliable ordered net delivery method, and the sequence channel is 1 for rotate move message. Next, we have fire missile message. It also has serialized, deserialized method, executing method, recycle. The implement of this class recycle method called message pool manager recycle method to return the message to its associated message pool. Frequency of use for the fire missile game state is low, only be used when the fire missile input occur and the message should be reachable. So my program use reliable ordered net delivery method and sequence channel 1 for the fire missile message. Next, we have lay mine message. So this class is also inherent from the data message of player class. It implements the serialized and deserialized method to call the associated method of its superclass. Here's the executing method. The frequency of use for this class to both server and client used is low. This message should be reachable. So my program used the reliable ordered net delivery method and sequence channel 1 for this class. Moving on, next we have fire input message class. So same as before, serialized, deserialized function, doing execute function. So the frequency of use for the fire missile input, sent from client to the server or from server to the server, used in game same play update method is low, and this method should be reachable. I also use reliable ordered net delivery method and sequence channel 1 for this class. Now we have lay input message class inherent from data message of player class. Implement serialized, deserialized function, and also implement execute function. It create a lay mine message with local and network as the destination and add it to the message queue manager's output queue. The implement of the let input messages class recycle method. It also calls the message pool manager. So the frequency is low and the message should be reachable. Reliable. So reliable ordered net delivery method. Sequence channel 1. Now go back to the diagram. Ship position and angle message, and also missile position and angle message. Those two class will be discussed in two different predictive algorithms. So right now for client side player prediction algorithm, this class is inherent from data message of player class, include two data field, one position, and one angle data field. So it has serialized deserialized method. Also execute method execute the player 1 or player 2 ships. Uh, uh, Player prediction and control superclass side method. The implementation for the recycle method is also done by calling the message pool manager. So the frequency is high and the message no need to be reachable. So uh, when the player type of this class is for player 1, my program will use unreliable sequence net delivery method and sequence channel 2. But when the player type is for player 2, it's also unreliable sequence, but the sequence channel will be 4 for this class. Now for the dead reckoning algorithm, since will become a little bit different. So now it has 4 data field, the T data field. So the position and angle data field is still there, but we have T data field and velocity. So it also has serialized and deserialized method. To serialize and deserialize the new data field, the T and the velocity data field. So this class also has execute method. It will execute the player 1 or players 2 ships, player prediction control super class set method. Uh, uh, those recycle stay the same, so the frequency now is high, and the method no need to be reachable. So for player 1, my program use unreliable sequence net delivery method and sequence channel 2. For player 2, unreliable sequence, but sequence channel 4. Okay, so that's for the ship message. Go back to this one. Now we have missile position and angle message. It's pretty much the same. So serialized, deserialized message, execute, recycle, down by calling the pool manager. So now it has 3 data field: the object ID data field, position data field, and the angle data field. So the frequency is high and the message is no need to be reachable. When the player type is player 1, I will use unreliable sequence net delivery method, sequence channel 3. But when the player type is player 2, so I will still unreliable sequence net delivery method, but the sequence channel number is now 5. Now for the dead reckoning algorithm, go to the missile and angle. So now we have we add T and the velocity into it. So now the frequency is high and the message is no need to be reachable. When the player type is 1, the net delivery method is still unreliable sequence, but the sequence channel is 3. And when the player type is 2, the sequence channel now becomes to 5. Finally, We have a collision event message inherent from data message directly. So it has two additional data fields: object ID A, object ID 2. Which are second data field and third data field to be serialized. Uh, so for executing method, it calls the game calls the game manager's class fan method to fan the game object A and game object B, and then call the game accept method. Um, the implementation for the recycle method is also called the method pool manager recycle method to return the message to its associate message pool. The frequency is low, only be used when collision event occur, and this message should be reachable. So I use reliable ordered and asynchronous channel 1 for this collision event message. Now go back to our diagram for we have time request message class. Uh, it has one additional data field, which is T1 data field. Um, which are the second data field to be serialized. Uh, the, ser this class also implements the execute function. It creates the time reply message, which network as a destination sets time reply messages T1 data field and the T data field and add it to the message queue manager's output queue. The implement of the time request message class is recycle method calls the message pool manager recycle message to return the message to its associated message pool. Frequency of use of the time request message for synchronized clock uh, is low, can only be used when the client connect the server and the message should be reachable. So reliable order net delivery method and sequence channel 1 for the time request message. Finally, I believe the last class time relay message T00 and T data field serialized deserialized functions for and also implementing execute method core time it calls the time manager class set time method the so it also has it also has a recycle method. The frequency for this one, for synchronized clock, is low because it's also only be used for time request message, and this message should be reachable. So reliable ordered net delivery method and sequence channel 1 for this time reply message class. Now we need to talk something about the message pool. So my message pool class implements a message pool mechanism. It uses a generic of C# language and requires its atom type to inherit from the double link node class in the front. We know that all of the message class are inherited from double link node, like the diagram shows, and should have a default constructor method. Let's go back to right here. So my message pool make use of double link list for the active message list. So here you can see active list and the reserve, as well as the reserve message list. Now my message pool fetch function, I believe right here. So fetch a message. In my implementation of message pools fetch function, it will check whether the reserve message list has any element. If the reserve message list is empty, then the program will create some new message and add to the reserve message list. then the program remove a message from the reserve message list, add the message to the active message list, and return the message. It's very similar to what we have in the Space Invader program. So message pull recycle function, cycle right here. Recycle back a specify message. In my implement of the message pulls recycle function, the program remove the specific message from the active message list, add the message to the reserve message list. My program creates a message pool manager class to manage the message pool list for all the 10 type of message, because the game only require one message pool manager instance, so it also use singleton pattern. It should be shown here. Where's the manager? So yeah, singleton pattern. So my message pool manager fetch function. So right here, fetch a message from its associate message pool. So the manager recycle function also return back a specific message to its associate message pool. And yeah, that's it for the message part. Now, number 5, record and playback to. Let me demonstrate first. So we have our server over here, goes to record mode. Same for the client mode, client side. So server start and client start. Now can do some server can do some actions. Relay 3 mines, maybe kill ship for the client part. Move the ship, set a few mines. Oh, and we kill ourselves. Yeah, I think that's enough. So close. Let me switch back to playback mode. And now we start server, and we should replay everything we just did. Yep. 3 mines. Let's just do some shooting. And now I start control client. With the suicide bomb. And yeah, I think that's it for the demonstration part. Now we need to talk a little bit more detailed part. What I was doing is a little bit tricky. So for the recording part mode, I created this record file writer class, to respond for serialize and record the execute time and data of each message. It's a singleton. I use singleton design pattern, so it has open record file method, which is here and here. For recording, and it will open a file and start recording. So it also has serialized method, to serialize and record the execute time and data of each message to the record file. So it also has a flash function to flash all the message data in the record file's internal buffer to the record file. So I use a try catch block around the game.run in the main function, and call the record file. Call this function flash function method in the final block. So in the constructor method of my message queue management, if I can find it. So here, the program will open a record file in my in my manager class. The process in method before the incoming being acted upon, the program will call record file reader class serialize public static method to serialize and record the current time as the messages execute time and the date and the data of the message to the record file. So which will be shown here. So when the program exists normally or crash while in recording mode, the program will execute the final block of the track catch block around the main function that I just said, and call the function flush message function to flush all the message data in the record file's internal buffer to the record field. And for the playback mode in the constructor method, the program will read and deserialize the execute time and data of each message from a specific record file to the data queue's input queue for later executing, which we can be shown here. So if we go to the message queue manager class processing, so the time reply incoming messages will immediate set the client's current time. Other type of income messages will not be triggered and act upon until the game's current time each reach the message's execute time. This will make sure that the messages are triggered at correct time. And if we go up, this private static method, add to output queue. Outcoming messages from the game will not be added to the output queue, and for the add to the queue method, static method, incoming message from the linearing will not be added to the input queue, because in the playback mode, the network is not being used, and all the message added to the output queue will not be processed. So that those two actions make sure that actions requiring messages being sent out while in playback mode will not be added to the output queue. Now for part 6, clock synchronization. So let me first demonstrate this for you. So data reckoning algorithm, this is server, this is client side. So as you can see, the server's current time is 6, 7, 8, and if I click space for the client, and yeah, their current time is being synchronized. So in order to do this, there's two messages that are required for the synchronization for synchronizing the clock. So the time request message and time reply message, as we discussed in the front. So when the client connect to the server, the client will create a time request message with network as destination, set time request messages T0 data field added to the message queue manager's output queue, and then send to the server. So yep, that's what I'm talking about. So when the server receives the time request message, it will call the time request message class execute So it will call the execute function. This will create a time reply message with network as destination set time reply messages T00 data field and the T data field, and so it goes back there, and you can see the math here. When the client receives the T time reply message, it will call this function execute method. So use a Christian algorithm to compute the service actual time. Call the time managers class set time method with the time time t plus t1 minus this t0 divided by 2, so that this time the client can correctly synchronize its clock to the server's clock. Okay, so part 7 for player prediction predictive algorithm. In order to demonstrate that the algorithm performance is much better than the one with no algorithm version. So I set a extreme bad network condition. So the simulated loss is 0.9, medium latency 0.1, and random latency to 0.01. So let's take a look. How does it look like with no algorithm version? Let's start with server, then the client. Let me start. So this is server. As you can see clearly that on the client side, our blue chip is really lagging. And if I control the client, it's even lagging more. And so that's how does it look for the versions without any algorithm. Now, in contrast, we have the version with our algorithm, player prediction algorithm. So with the same extreme network setting, 0.9, 0.1, 0.01. Let me show you the difference between those two versions. Server, client, display. So server. Although you can still feel in this kind of extreme network latency, you can still feel it's jaggering, but it definitely feels better than the one that I just show you without any algorithm. So yeah, that's a demonstration for the algorithm. So for this player prediction algorithm, in my client side, let me go. So I create the player prediction control class to implement the player's prediction algorithm with target chasing. It has 4 public methods. So get prediction position, get prediction angle, and set and predict position. So the set function set the position and angle set from the server by the the shape position and angle method, as well as the missile position and angle method, which is to object that we are predicting. So the predict position method predict the position and angle of the game game object. So in this algorithm, the skip class now inherent from the player prediction control class. Let me see if I can find the ship class. So now it's inherent from the player prediction control class and as well as the missile. Yep. So the which target chasing will predict predict and position and will predict the position and angle of player one's ship or the player one's missile, player two's ship, as well as all the players two's missile. So now we need to talk about the predict algorithm. So for each object to predict, it starts with an initial data. So we have at time t, the object has position p and velocity v. So we have set call right here from those two messages. So when a new position message arrive with position P and angle A, note that arrival time T, compute the velocity. So this line right over here, based on the previous data and newly arrived data. So now we have updated data to predict our future position. So at time t, the object should be at position p with velocity v. So for each frame, we'll use our most recent predicted data to compute my expected position. So next position is p plus the current p plus the current time minus the t times v. So the next angle is a, and the next angle predicted angle is a. So the client side will update this newly predicted position and angle of the object. Or time for the execute target chasing method. So in order to implement this algorithm, I will adjust the predicted the next position and next angle to a value that is more, near to the older position over 1 second by by the following method. So predict position equals to the predict position plus old position minus p times 1 minus as a factor. The predict angle equals to predict angle plus old angle minus the angle times 1 minus interpolate factor. So this method will interpolate between the old and new position over the second times. So now the dead reckoning algorithm. So in order to just go through, so I set the simulate loss to 0.5, minimum latency for 0.1, and random latency for 0.01. So in order to demonstrate you the performance, so first of all, at first I will demonstrate the player prediction algorithm first. So now the server and the client try to watch the difference between the message, how many number of messages that the player predicted algorithm that is sending. So I'll go. So as you can see on the left side of the screen, you can see the message number sent by the server is almost for it's not like 10 seconds, for almost like 8,000 messages is already been sent. And I can move the client. Still quite lagging because how extreme network we are setting. Yeah, so just for the simple 30 minutes, there's like 160 message has been sent. So remember that number. Now I just switched to the data reckoning algorithm version. So let's go for the server, and then the client. Again, in extreme bad network condition. So, oops. What's the left top number for the message number sent by the server? You can see it's growing very slow. So 400, 450, 500. Go for the client side. Can lay some lines. And yeah, so notice that even the server now is using the net delivery method, unreliable sequence method to send the position and the angle of the ships and the missile to the client. The data reckoning player prediction algorithm will, with target chasing version, will still works fine. And yeah, that's it for the demonstration. Now let's talk about some code. So in this algorithm, for go to the queue, the message. So we know the ship position and angle message. We now will have four. We'll now have four data field instead of two. So we have server time t, ship position, ship angle, and the ship velocity. So now in missile position and angle message, now we have five data field right now, which is the object ID, the server's missiles ID, server time t, server missiles position, angles, and velocity. So same as before, for data reckoning algorithm, I also create the player prediction control class. So it also has those functions: get prediction position, get prediction angle, set, and predict position. Well, the difference is that this class now include two constants. So the position threshold is 2, angle threshold is 2 as well. Now that in server side, in the game same play class side, so here, so if you go down to see, right here, so only when in the server the distance between the predict position of an object and the true position of an object is greater than or equal to the position threshold constant, or when the server the distance between the predict angle of an object and the true angle of an object is greater or equal to the angle threshold constant, the server will send the ship those two class that I just mentioned that include the server's current time, the position of the object, the angle, the velocity, to both server and the client. As you can see, here's conditioning to check the angle, conditioning to check angle as well, but with two different message type. So one for the ship position and angle, and one for the missile position and angle. Now, the data reckoning predict algorithm will target the same object, which is position and angle of player one's ship or the player one's missile, player two's ship or the player two's missile. And if I go back to the player prediction control, the math is different. So now at time t, the object has a position p and velocity v. This won't change. However, compute the position p based on the arrival time t and the newly arrived time. So the formula right here, this position may be as same as the object's true position. Update time client object's velocity to v and angle a. So now we have update data to predict our future position. At time t, the object should be at position p with velocity v. So now with our predicted information, the predicted position is now equals to p plus v times current time minus t, and predicted angle is a. No, I'm sorry. Is predicted next angle, and for the execute target chasing. Now only the client side player, prediction control can execute the target chasing algorithm. So we'll go to the client side. So to implement the target chasing algorithm, we adjust the predicted next position and next angle, with interpolate factor. It's the same with player prediction algorithm. So this method will interpolate, between the old and new position over 1 second's time. And yeah, that's it. Thank you.